issues that we seem to be having thus far.
Yeah, I just can't
Okay. Let me start with one quick thing on the bottom, and then I'll come back up to this little fractions thing that I've got up top. And if there's any time that some of you are going to focus, this isn't the time to be scribbling around going with like 3 assignments ago. You need to be kind of playing with what we are here. Some of you are still getting confused on what an up or down shift is versus left or right. If you don't see parentheses, okay, the only time we're doing left or right shifts are when there's parentheses. So if you see a plus or a minus there otherwise, whether it's outside the parentheses or there's no parentheses at all, those are when we're going up and down. And again, up and down ones are straight what you see. If it's plus, you're going up. If it's minus, you're going down. But if it's in the parentheses with your x or with a theta, okay, that again is the opposite of what you're doing. And we'll get into how to actually play with all the shifts again here in a minute. But that's one thing on the basics that you've got to have right off the bat. The other thing that we seem to be having issues with is period changes. Okay? Period changes, everything bases off of what you see here. You're like, well, where's the pi? Because again, we know that when we do the periods typically are 2 pi, unless I change something. I think the pi is what's messing some of you up. So for instance, if you saw something like cosine 3x or 3 theta, you know that you're going to divide your period by 3. So some of you are like, okay, I can do that. You know, p is 2 pi over 3. But that's when all panic sets in. Because you start looking at these and you're like, well, okay, so this one's 2 pi over 3. And this one is 0. And this one, if I go ahead and put my pi into all of these, okay, well, that's just pi divided by 3. Okay, you know, I can follow that. But those 2 other ones where the denominator changes, what do I do? Well, remember, especially when you're looking at one of these that's fractional, just think for a second on how it would work, or maybe do a little bit of work even in it. Okay, so if I've got 1/2 pi, and I'm dividing it by 3, remember, that's the same as multiplying it by a third, or its reciprocal. Take a second and then just write it. Pi over 6. Okay, that's all right, that works. Same thing here. It's 3 pi over 2 normally, but I'm just dividing, or in this case multiplying, by the 1/3. Now this one, there's a little extra little bit, because when I multiply across, I can reduce the fraction because 3 over 6 is 1/2. But that's the type process you have to work through. And I'll even say it, I can't believe I'm saying it, but I'm going to say it. If you have to, okay, without the pi, if some of you got to here and you have to, okay, 3 divided by 2 divided by 3, oh, 0.5. It's 1/2. Math, enter. So it's pi over 2. I just put the pi back into the numerator. And it's the same if I had to do it here. So if that's the point that you're at, that's the only way you can survive getting there, do it, okay? 1/6, pi over 6. That's okay. But don't make that your reason for not doing it. Okay, let me move this out of the way. Because again, when you get the fractional ones, you're just multiplying by 2. Now you're all good with the 0. Dividing by 1/2 or timesing by 2 would make this 4 pi. And then you guys are like, well, the middle's half of that. It's 2 pi. Oh, between 0 and 2 pi is pi. Right. 1/2 times 2 is 1. Okay. 3/2 times 2, 6 over 2. Don't make it hard just because pi is there. Okay. Treat it like a variable, or just ignore it until at the very end and then stick it back in and work it from there. So, with that in mind, put this over here for a second. All right, 39 in the book I've had requested, and then if we want to jump to some of the ones in other places too, we can do that. All right, so 39. 1 plus 5 cosine x minus pi. Okay, let's see what we got working here. we have got this 1 in front would be the same as if I had a plus 1 at the end. So this guy here tells me I'm going to be shifting up 1. I have a coefficient in front of my cosine. So this guy tells me my amplitude is going to be 5. So we're going to be stretching way up and way down. And then this minus pi, now what's that mean? Okay, we're going to be shifting right a whole pi. Okay? So you're like, oh, that's a lot of stuff to keep track of. Okay, but it's nothing that we can't do with a little bit of patience here. Did my period change at all? No. So my period is still going to be 2 pi. At this point, I would hope that you can rattle that off like the back of your hand. And then you start looking, you're like, okay, so normally at this point, I've got a few things going. My first thing is I need to take my radian measure and I need to shift it right pi. In other words, I need to add pi to all of my radian measures. Okay. So I got pi, then the fun starts. Well, I can do my easy ones right away.
Pi.
Yeah, basically between 1 and 2 would be 1.5, or 3 pi over 2, because that's just my improper fraction for 1.5. What? Yep, one's my improper fraction for 2.5. Now, here's one more thing you can do. Again, it's a backup plan. Because some of you will know, well, okay, I know that's 2.5, but I don't know how to do the fraction part. Okay, 2.5, math, enter, enter. 5 pi over 2. So again, if you need to do that, okay? Don't let that stop you. Okay, so we've got the shift taken care of. So then you're like, okay, so then we're going to get crazy on this one just because, again, there's a lot of things going on. My amplitude's what I'm going to deal with next. Okay, so I'm going to take my value, I'm going to times it by 5. Yes. So we're dealing with cosine here, so what do we normally start with? Okay, we normally start with 1, and if I think about it for a minute, I'm like, okay, there's what I normally start with. I'm going to times them all by 5. So I'd have 5, 0, oops, positive, negative 5, 0, 5. But I still have to shift them all up 1. Now, could I have done that here in one big swoop? Probably. But I want you to see the thought process that goes through. So take all those, and I'm going up 1 with each of them. So what you see in red is what we're actually going to end up plotting. These were just there to give me a visual of what I needed to do to each part. Now again, if you can get straight to this and this, I don't care, but I'm going to see something for this. Because I have a hard time, I guess I could find out on a quiz, but I have a hard time believing some of you can whip through this with no charts, no nothing, just bang, you're just that good. Now, maybe. So I'm just going to go by 2s instead of going by 1s here. And I start looking at all of this. Now, here's the other thing on this one. With this shifting everything right pi, you still want every one of your quarter points to have the same value. So even though I'm starting at pi and then going up another, half each time, I do need to be consistent with what I'm doing. So some of you are like, okay, so if you just do it by pi, that would mean the ones in between were pi over 2, 3 pi over 2, Now, I'm just writing these in to let you see where they're at again. If you just put pi and 2 pi and 3 pi and can figure that out, that's okay. So my first dot won't be back at 0, it's going to be at pi. So pi 6, 3 pi over 2, we're down to 1. 2 pi, we're down to negative 4. 5 pi over 2, we're back up to 1. And 3 pi, we're back up to 6. And off we go. So can there be a lot of things going on? Absolutely. Okay? But that's why you take things in bite-sized pieces instead of trying to go, I got to do this all in 5 seconds. So that actually probably would be one of the most complicated ones you would see, except when you had to factor something out. But then it'd be the exact same thing. We got a little of everything in there. Nice choice. It lets us see a little bit of how everything works. What else? What else? And just a reminder on this one, whether it's today or whether it's tomorrow on this one in the worksheet, they're still on time either day. So, you know, if just seeing some of this kind of gave you that extra little something to get going, that's fine. You're still good going into tomorrow. And there'll still be a key up here if you need to see it. Any others that we want to take a closer peek at? Because we will be seeing this again in the preview on Wednesday too. Okay, for some of you who haven't liked the graphing, you may like what's coming here. Could be something a little bit different for you. Okay. The last of our trig stuff, as some of you quietly cheer in your minds. Verifying trig identities. This is, I guess, what I would call it if I was going to make a comparison is I call this the proofs of trig. Because it's like proofs. So basically what we're going to do is, and you will never be without this chart that you see up here at the top. Okay? So do not go into panic. You do not have to have these memorized. Okay. It'd be good to know them because there are 2 or 3 questions on the ACT that have to do with trig stuff. A lot of it shows up with identity stuff, so if you can remember just a little bit of it, it could come in handy for you. But here's the first thing I want to make mention of. Okay. Our goal with trig identities is you always want to try and get everything into sine and cosine. And the reason that is because even when you get into tangent and stuff like that, you can kind of manipulate it into sine and cosine, and you have better chances of things canceling out. So anytime I see tangent or cotangent, I'm automatically going to start thinking, okay, how can I get this into sine and cosine? Because then I can start canceling things. So that's always my #1 goal. So reciprocal identities, as you can sort of imagine, okay, so cosecant, oh, I can turn that into sine. Okay, secant I can turn into cosine. This we don't use very often. It might come in handy every once in a while, but usually not. These are more of what we'll use with tangent. Okay, tangent and cotangent, because why? Well, because I'm turning them into sine and cosine. Doesn't make sense yet, will soon. But the one thing I wanted to do that's not done on here that'll help you out is understanding how I can manipulate these some. Sine squared plus cosine squared equals 1. That's great. But what if I just see sine squared sometime? For instance, if I wanted to get sine squared by itself, what would I have to do?
Subtract cosine squared.
Okay, so sine squared equals 1 minus cosine squared. That could come in handy if you see a sine squared sometime. The same thing goes for cosine. If I wanted to get cosine by itself, what would I do? Same thing. Okay. Those could come in handy. And it works the same way with the others. Now, I'm not going to go crazy and do it for every single one, but just to, again, show the idea, if I wanted to get tangent by itself, I'd subtract the 1 over. Okay. And the same thing with cotangent. So you're like, okay, so basically what you're telling me is that I'm going to be doing something with all of these where I'm just going to be using these pieces up here to kind of solve puzzles. Yes. Okay. And we're going to do it in two ways. Sometimes we're just going to simplify the expressions as much as we can, and sometimes we're actually going to have to prove something. So here's how this works. When I'm looking to simplify an expression, again, anytime I see something that's not, and I'm not going to literally cross that out, but I'm kind of mentally crossing it out. If I see cotangent, what's its equivalent up in my little chart up here?
Cosine.
Cosine over sine. So I'd have cosine x over sine of x. And what is secant's other identity? 1 over cosine. So once I get them into their new identities, these work just like any time that I'm multiplying fractions together. Anything cancel? The cosine x's cancel. And what I'm left with is 1 over sine x, and if I look up top, I see, oh, that's cosecant. Okay. So basically what I'm doing is I'm manipulating these into sine and cosine so I can cancel stuff out and reduce it. Kind of strange, but kind of neat at the same time. So on B, for instance, okay, what does my first term turn into?
1 over sine.
1 over sine, because I found cosecant right here. What about tangent?
Sine over cosine.
Sine over cosine. Once you manipulate, cancel if anything is cancelable. I end up with 1 over cosine, which is the equivalent of what?
Secant.
Secant. And again, being able to do this simplifying is going to help us when we get to the next part with verifying our trig identities. Now this next part gets a little more interesting. When I get to here, you're like, ugh. Now do I just start, you know, what do I start doing here?
Foil it together.
Yes, this has to be foiled. So you start looking like, okay, so secant times secant is secant squared. So then I do my outer, which would be minus 1 secant x. But then look what's inside. Positive 1 secant x. So they cancel. Negative 1 secant, positive 1 secant cancel. And it's interesting how this just happens to work out. Because before I go start messing with stuff, do I see secant squared minus 1 anywhere? Mm-hmm. Secant squared minus 1 is actually tangent squared. And I know the question that will be coming next. So are we going to turn this all into sine and cosine? No, because this is the equivalent. And here's where we're going to have to start thinking less abstractly again. This is the equivalent of looking at something, and don't write this. It'd be looking like, what would you do if you had x squared over x? What would that equal? X, because you just subtract the exponents. Same thing here. So it just ends up being tangent of x, because this tangent and that exponent part would end up canceling each other, or reducing, just like an exponent would. Okay. So that's part of what we're allowed to be able to do. Now when it actually comes to the verifying, which is the more legitimate part of this is more like a proof. So here's how this is going to work. We'll read the directions at the bottom before we flip over here. So we got to follow the directions. Similar to proofs, we got to show every little step that we're doing to explain what we're doing. So we're going to make trades. We're going to reduce and cancel things to make the left side look like the right. And I don't know why this says there's a few rules, because there's only 2. You must show every single trade and thing that you do. There's no doing this in your head. And you can't touch the right side of the equation. We're going to manipulate the left side to make it look like the right at the end. And those are the only two rules. Oh boy. So get ready to flip back and forth because our identities that we have up here at the top are going to help us out a lot. So here we go. Okay. Verify. Now, so I don't think about it, I cannot, under any circumstances, touch the right side of the equation. I cannot touch that secant. So, I look at the left side and I go, okay, well, what can I turn tangent into? Sine over cosine. Okay.
One sine.
Okay, and cosecant is 1 over sine. And just kind of keep looking and flipping as you go and go. I mean, let it sink in a little bit here. You're like, all right, so can I cancel anything?
Sine.
I can cancel the signs at this point. Because again, this is just like a regular fraction is. So those wipe out. And I end up with 1 over cosine of x. What's 1 over cosine of x equal? Secant x, check. Because now I've just made this look like the right side. And this will work every time. Sometimes it'll go fast, sometimes there's a little more thought process to it. But that's all I'm doing with these. So, letter B. What's tangent become? Sine over cosine. And just like these, like anything else, the more you start to play, the easier this is going to get. Cosecant? 1 over sine. And before you go canceling, just finish all three of these off. And cosine's already itself. Leave it alone. Okay, if something is already sine or cosine, don't touch it right away. Because usually it takes care of itself. And what ends up happening? Everything cancel because those cancel. I'm left with 1 and I'm done.
1 over 1 equals 1.
1 over 1 equals 1. It's true. So this is just really like taking some puzzle pieces and kind of playing with it. So, oh, one of our favorite things, fractions. Yeah. All right. Sine is itself. Leave it alone. Okay. Right. Cosecant is 1 over sine. Okay. I would suggest just doing one thing at a time. And again, I'm not touching that one. Now here's one of those things that we have to think about a little bit. Let's do a little side play here. So I have sine of x, and I'm dividing by 1 over sine of x. What do you do to the second fraction when you're dividing?
Flip to reciprocal.
Flip it. Take its reciprocal. So this is really sine of x times sine of x. And again, if you can just visually look at that, that's fine. If you need to do this, that's fine. And that ends up being sine squared of x. So when I come back over here, this is sine squared plus cosine squared. And if you look over on the other side, you notice one of your identities is sine squared of x plus cosine of squared of x equals 1. Check. But you're going to have to do some manipulating. You've got to play with fractions. And this is one of those situations you can't even plug it in the calculator. What the heck? But that's how I would deal with this. Anytime you get into a complex fraction, that you're dividing a fraction by a fraction, a little side work could come in very, very handy for you. So let's see here. D. Ooh, more fractioning. What is cotangent when I'm turning it into sine and cosine?
Cosine over sine.
Okay, so cosine over sine times, whoops, I'm thinking ahead. Okay, and yes, I'm turning the cosine into a fraction just so I'm thinking that way. this big. What's cosecant going to be? In reference to sine or cosine? 1 over sine. And again, if you're not flipping and looking back and forth right now, you're doing yourself a disservice. So I look at this and I go, okay, so if I kind of keep going with the way this is, I've got I've got cosine times cosine would be cosine squared x over sine of x. And I just got done telling myself that if you're dividing by a fraction, you're multiplying by its reciprocal. Which is what I'm going to do. So I notice these cancel out. And I'm just left with cosine squared x. But if I flip back over to the front, which I'm going to do, it paid off that I manipulated this. Cosine squared of x equals 1 minus sine squared of x. Hey, 1 minus sine squared of x. How convenient. So just when you think all hope is lost or something has gotten hard, you usually find that, oh, I did all this right. This is good. So it's just continuing to play the manipulation game. All right, let's keep playing here a little. What should I do with sine? Leave it. What's 1 plus cotangent squared equal?
Cosine.
1 plus cotangent squared is cosecant squared. Okay, let's do that for right now. Okay, so I start to look at this, and I'm like, I want to get cosecant x at the end. So now I have a choice. I can play here. What if I wanted to manipulate sine of x? Do I want to? Here's the one thing I will give you a forewarning about. You look at this, and you go, well, the only thing I see on the back that I could do to this is to take it back where it was. Here isn't actually an option for you. Even though cosecant of x, okay, is 1 over sine of x, cosecant squared of x, this is perfectly legitimate and legal, could be 1 over sine squared of x. Okay? You can do that. It's just like using any regular, exponent rule that you would. So if I want to do that, I could do sine of x times 1 over sine squared of x. And you're like, okay, so then what? Well, the sine of x can wipe out one of these, okay, the squared part, leaving me with 1 over sine of x. And if I flip that, you're like, well, wait a minute, I don't see that anywhere on the front. Yeah, because if you think about it and you go back to the front for a second, if I were to say I wanted to make one of these for sine, and I normally don't because I'd like everything to be sine and cosine, I could multiply by sine and then divide by cosine. So if I wanted to, I could also take inverses of both of those if I wanted to. I won't use these very often, but just in case, it's not a bad idea to have and be prepared for, because that allowed us to get to what we were looking for. So now, I left the humdinger for the end. You're like, oh boy. Okay, we got this. Should I do anything to this? Probably not. I might have to later, but for now, let's just leave that alone. What does secant become? 1 over cosine. And then that I'm going to leave alone for a second here because I see sine and cosine, and normally that ends up being a good thing for me. Look at the fraction inside of your parentheses. Because since they have a common denominator, okay, that's really just one big fraction. So when I'm looking to simplify, I'm like, well, wait a minute. What's 1 minus sine squared going to equal? Does 1 minus sine squared equal anything? Cosine squared. Interesting how this works out, because all of a sudden you look now and you multiply across and you're like, okay, so 1 times cosine squared is cosine squared. Cosine times cosine is cosine squared. And whenever I divide something by itself, I get 1. Woohoo! So your job is to deal with the worksheet that came along with it. Tomorrow, there won't be anything new. It will be working on more of these identities, and if some of you are still having some issues with the graphing, we can take care of that. But that is what you've got on your plate.